As part of the data structures programming, we'll see now the concept of linked lists. Hello everyone, this is Shravan Kumar Manthri. Welcome to our channel CSE Gurus. Of course, there are types of linked lists, single linked list, double and circular we have. Anyway, right now we are first go with single linked list, how it is. After that we'll go for the double linked list also, circular also. We'll do the programs, we'll execute everything. So these are the programs anyway we are dealing right now, all the programs. And one more thing I want to highlight here, for each one we can have, for example, inserting a node at the beginning. What are the complexities? The best program we need to write actually. Creating a node, I think only to create a node. If I'll write a program where creating a node in the sense where if the list is empty, it will take the node as current node as the element in the list. If list is already consists the elements, everything will be erased and yes, current node in fresh it will create a new linked list. That is what the purpose of creating a node, which always with the complexity 1 you can get the answer. Insert a node, again I'll keep it with 1. Insert node at end, I'll make it in two ways, n or 1. Both I can make it by taking an extra what you call as variable. I'll explain that also. Two programs. Inserting node at a given position, so you need to traverse to the position, right? You need to go to the position, definitely it is big of n. And delete node at the beginning, which is definitely 1. Delete node at the end, yes, it is not 1, it is even if I take n, you can get it, you cannot get it with 1. Delete node at a given position also n actually, but when you go to there, the remaining element cannot be changed except the element which is next to it. Okay, so that means when you go to that position, the complexity will become 1. From that I'm talking about. Even in the arrays also, when you go to a particular position, from that what you need to do means, if you go to there, yes, from that complexity is 1 only. We are not writing any loop further. So anyway, to go for it, we have to write a loop. So the next one is displaying the elements, you can see. So which is n complexity, and of course the count, which is n complexity, which is absolutely fine, and search in the worst case it is n complexity. Okay, this is what we are going right now, and the thing which is important is how easily we can write the programs without any worry, step by step. That is what we'll see here. And of course 3 things which you need to go for when you want to go for linked lists. You can revise once you go for this programming of linked list. The first one is pointers. Second one is DMA, which is dynamic memory allocation. Especially malloc is fine in the dynamic memory allocation. The third one is in the structures, self-referential structure. So these 3 things are very most important when you go for the concept of linked list. If you know all this, yes, it will be a cakewalk for you. The concept of linked list, the program which you want to write. So I'll write this one, you can see all these things. Now I'm starting my programming. Starting with the first one, I need to declare a linked list. For that I'll take the help of a self-referential structure. That's why I'll write a struct, a node to be created, actually to declare struct node. I'll write like this: struct node when you open, which consists 2 parts. One is data part, the other one is next part, which stores the structure next. So which is that's what I told you, struct node, the same name where you want to store the next, which is a self-referential structure. Like this we need to consider. Now what happened if I write like this? So when you write like this, a structure is defined here, where structure node is defined here. Let us suppose a node will be like this, which has 2 parts like this. A node, this is a node where it consists, the first one is the data part, other one is the next part. Like this we have done as of now. Now once it is done, now you need to go for creating the objects for this. How to create the objects? Initially we have to take a basic node called as head node, where you have to start struct node. I'm creating an object for the structure. Through that objects only we have to access the elements of the node, fields of the node. Anyway, fields of the structure, variables of the structure are called as fields, so I can access. So I'll create a node called as, which is a pointer object where head is equals to, anyway here initially I'll make it as null first. So that means the intention here of making this one here is struct head is null, means I created a node where my structure, linked list will have null here. Null in the sense, so this is a head node. If head node is null means my linked list is empty. As of now, no element is taken into the linked list as of now. Okay, I'll make it this one and I'll ignore this one as of now. So why? Because I have just taken head node where the value is null, nothing is given here. Anyway, it is a data which will take only to store the address of the first node. Head node is always used to store the address of the first node in the linked list. So till now we didn't take any first node, so that's why here I'll keep it as null. Now I'll write a program with menu driven. Menu driven means we'll give the options asking the users to make the things out, which option they want to select among that. Anyway, we are writing with the many options and we want to check it out which is the best one. So this is what we can go here. Now I want to take here as the choice from the user, that's why I'll take ch, where user have to give the choice. What is his choice? Anyway, it's a menu driven. Which choice he wants? He wants to create a node, he wants to insert a node at the beginning, at the ending, like this. Anyway, I don't want to write everything first, but with explanation I'll show. Right, I'm taking the choice from the user, and what are the choices I want to give initially. So I'm writing here printf, I'm asking the user enter your choice. So clearly you can also write parallelly with me and you can execute. Enter your choice. The choices are printf, the option 1 create, means creating a node, simply creating a node. Option 2 I'll take create and insert and display, so that I'll get the clear picture like what we have done. Only 3 functions first. Create, insert means insert at beginning, okay, slowly I'm writing insert at beginning. Third one, display, after inserting at the beginning a node, how displaying the nodes. And after that, anyway, I'll write more functions will come, that's why I'll keep those numbers for that. Might be I'll take option 1 2 3. If you want you can take 4 for exit here. Yeah, I'll take 4 for exit. That means why exit is written here means I'll explain that also. Let us suppose user is asking some input and he wants to insert an element. Okay, for that I need to write. Anyway, I'll write here, you can see scanf. After getting the choice from the user, might be the user give choice 1 2 or 3 or 4. Okay, I'll write here switch case, switch choice, where 4 choices will be there. Case 1, as of now we have written. Anyway, I'll extend this program. Case 3, case 4, like this we have as of now. Now what is case 1? Case 1 is to create a node. When you want to create a node, first you need to give the value. With respect to that value, node will be created. So I need to enter the value. In order to get that, I'll write printf enter a value. So first we are writing enter a value, which value you want to insert. So once you read the value, that is scanf, when you read the value, scanf %, let us suppose value can be given as val, the value, where the value to be declared here val, which is a value. Now once you declare, you have to call a function to create a node. I'll create a function called as create with respect to the value. I'll call this function and break. Once this is done, once the create is done, that means it will be created with respect to a node, and you can see the part, right? So this is what creating a node. I want to write that first. I want to write what is the create function, so that you will clearly knows like what we are doing right now. So outside the main, I think I need to go. This is main has to be closed here, and I want to implement what is this create. So anyway, I'll write that create function here. So outside this, I want to create it. So void create with respect to a given value, the parameter value int x. In order to create a node, I'll create an object for this node. Struct node, a new node which is nn. I'm creating a node nn. So what is this nn? Nn means, let us suppose as of now we have like this, a node which is head node, which is null you have as of now. As of now null you have. Now I want to create a node here which is new node. Let me write here. I want to create a node here. First thing, which consists two parts, data and address part, which has to be assigned with some address. As of now I just created a node. What is the address of that node? Now I need to assign the address with respect to the memory allocation. Anyway, it's a pointer, we need to allocate the memory dynamically. So what is the address of the nn is, I'm going with the malloc function, malloc of how much it is needed. Actually, of course, malloc you need to give the size. So malloc of how much you need is size of how much the struct node is needed. How much the struct node is needed, those much I have to allocate. So where the type conversion, the type casting has to be done here, which is struct node asterisk. So this is also to be given, so that now the thing happens here is nn means it is a some address which it has to start. Let us suppose something like, I'll write address 2000, where it will allocate the memory how much size of struct node consists. So anyway, initially we have written struct node will consist a data part and to store and address part to store. Anyway, both are integers which takes 4 plus 4, 8 bytes. So it will allocate starting with nn. It might be 2000 up to 2007, right? So like this, totally 8 bytes will be allotted. First 4 is for data, second 4 is to store the address of the next node. Now initially what are the values inside? Anyway, you created the address. Now what is the value inside of data? Nothing is there initially. So I want to assign with the data. What is the data input we have to give? Which is the value given right now, which is the value x, which is a parameter. Now we need to create a node, right? So what is the value inside? Whatever the value given here, that is the value x it is given. That with that x value I want to create here. So the value x has to be written here. Anyway, that value we are giving input. Now the next part is, what is the nn of next? Nothing is assigned to after this one, that's why I'll make it as null. So what happened here? So now the value is x and now it is null. So that means till now what we have done is we created a node nn, a new node, and this node consists the data part, which is the x value, which is the input value. For example, if it is 10, it will be 10 here, and the next is null. Now the address is nn, means it is something like 2000. Now we created a node, we have a node. Till now we didn't connect this node to the linked list. Why? Because if it is connected, this node should be the first node. It means this null should go over. Why? Because here it is null should be replaced with the address of this. That means in order to connect this 2000 should come here. So that what is head value now? 2000 means your linked list consists the first node as the node with the address 2000. So that is what, in order to make it establish, I'll write here one statement. The statement is head is equals to nn. Means what happens? What is head value? Previously null. Now it became what? It's 2000. In our example it is 2000. So that the 2000 is stored in the head node. So that's why the first node is this one. Now your linked list consists only one node, which is 10. So this is what happens when you want to create function executed. Simply nn of data, nn of next, and then head equals to nn. Yes, you connected. Now as I told you, even there are 10 nodes in the linked list. If you want to make it create, means all the 10 nodes will be removed, only one node exists, whatever the current node. That is what the create means, creating a fresh linked list. Now after this I want to go to the next function, insert beginning. Anyway, I'll show you the execution once it is done. Insert at the beginning. So for that I am writing here case 2. Anyway, insert at the beginning means again you need to insert the value here, you need to give the value here. I am writing the same, enter a value. I'll take the value. Now once you take the value, I want to write the function name as insert underscore begin. The function name is insert underscore begin, so that the value can be inserted at the beginning. So now I want to write here, you can see the function void insert underscore begin, where you have given one value which is int x. I want to go for it. You can see here how to write the program for this. Again, I want to create the node first of all. Anyway, I'll take the help of this entire. I want to take the node, I want to take the memory, I want to give the values. So till this it is common. See, so once you get one value, you can simply copy so that it will be easy. Now what happened? I created a node. Let us suppose I created a node here. Let us suppose here the node is 20. The value inside is 20. I created something, the address is 3000, and here I got the address 3000 and 20 is the value, and here it is null. Now I want to take this node which is to take into the linked list. How I can make it? Now how I can make it is, that means when you want to insert at the beginning means already there is a node 10. If you insert 20 at the beginning means your linked list should become 2010, not 1020, right? 20 followed by 10. Why? Because every time whatever the new node I am inserting at the beginning, not at the end. So this is a thing which you need to understand when you go for inserting the node at the beginning. Now there are two cases. What if there are no elements in the linked list? Then what you have to do? If there are elements in the linked list, what you want to do? If there are no elements in the linked list, your element new node will be the first node, and you can apply the same thing like create function, right? Now if already existing elements are there, what you need to do? Anyway, that also I'll explain. First thing, I'll make it, if there is no elements in the linked list means what? The first condition is, what if there are no elements in the linked list means what? Your head node value is equals to null. That is the condition. Means what is if head equals null? I told you linked list is empty. Now whatever the current node should be the node which you need to make it. So I can write this entire code, but can I write like this? Can I write create function to execute? Why? Because linked list is empty. Create of the current value x with respect to this. Yes, you can make it. So if head is equals null, yes, execute the create function where whatever the element is given will be directly inserted at the first. Else part, if it is not, head is not equals null, means there exists at least one node in the linked list. I hope you are able to follow. If at least one element in the linked list, what you need to do? Now this is the arrangement you have. Let us suppose that means your linked list have 10 and 13. Now you want to insert 20 at the beginning, means it should be 20, 10, 13. Now how you can make it? That means if this node should be the first node, the address 2000 should be here, right? Head node. That is what first thing you need to remember. And not only that, first thing is what? Your head node should be equals to 2000. That is the current node value. I want to write here. What is that change you need to do? Head is equals to NN, first thing. Second thing you can say, if this is the first node, the connection to be established like this, and here it is null, right, initially. So this should go to this one, right? So what is the NN of next should be this 1000. That means which is the previous head node value. So I'll write like this. First I'll keep it here. NN of next is equals to head node. If I write NN of next equals head node, means what? Here it will be, what is a head value? 1000. Yes. 1000 will be here, yes, which is connected. Now what is head node? NN means 2000. Now you can see the arrangement. What is head node? 2000 means the first node is this one. What is the next node after 20? What is the address? 1000. So where it goes? What is the value? 10. Now when I insert, did I change any next nodes replacement or did I update them? Now you can see the arrangement. What is the head node value? 2000. Yes, it goes to here. And what is the value? 20, the first node. And what is the next node? The address is 1000. What is the value inside of 1000? 10. Yes, perfect. What is the next is 3000, which is now, even if you can see, if I insert the node at the beginning, only the first node, whatever the previous have little bit changes, but whatever the next nodes, nothing to change, even if you have 1000 also. Okay, so that is what we can see. Anyway, I'll write the code. What are the two changes which we can do is, first thing is NN of next is equals to head node value to be assigned, and next, what is head node value? The head node value is equals to NN previous, that is NN has to be now updated. So that's it. We can make it so that whenever you want to insert a node at the beginning, you can make these two changes. So now we'll go for the third function, which is to display. What is this display? That means till now what are the elements in the linked list that I want to display. For that, no input parameters to be given. Whatever are there in the linked list has to be displayed. Display, then break. Like this we can make it. Now we'll write the display part here. Void display, where I want to traverse actually. Let us suppose the elements are like this and I have the displays 10, 20, 30. Now how I want to display here? So I'll take a temporary variable t which has to start from the head node initially, where this temporary variable which has to start from the head node, and I'll display what is the value inside that address. So what is temp? 1000 of the data 10. Yes. Now this temp has to shift here. So how to shift? I'll tell you. Next I'll display this 20. Next this temp has to shift. So like this it has to be shifted every time, and we'll get the value until your temp should become null. Whenever it is null, yes, you come out. So this is a loop when you have to display like this. But before that, I need to create a node called as temp node to make it struct temp initially, which is to start with head node. Now clearly it means to say it is, if you clearly observe with arrays concept. If you clearly observe with the concept of arrays, let us suppose I want to display the elements in an array where index starts with 0. Right, so we'll write I equals 0, right? So same thing like temp equals head, we are starting. And next we'll go for I plus plus. I'll tell you what is that I plus plus. So initial I equals 0 means this one. While I told you, like, while temp is not equals to null, what you want to display? You want to display it is printf percentage d. I'll keep something like arrow, so that is representation of a linked list like this. Of course, nothing technical to do with this. So we are printing what is the temp inside the value, which is the data. Once you print the data, go to the next one, which is temp should be updated to temp of next. So this is what the process will happen every time, similar to like if you consider arrays concept, where when you want to display the elements in an array, I starts with 0. Similarly, temp equals head means where you want to start. Now you will write I plus plus means going to the next. Here also temp equals temp of next, going to the next node. Now we will write I less than n. What is that I less than n means? You are going till the last index of the array. Here also, while temp is not equals null, which is the last node of the array, the condition. So this is what you can make, and you can display the elements in the array. Of course, as of now we made the things out. Let us try to execute this one. And one more thing we need to fill it up, I think. The button exit. Why exit is required, I'll tell you. And also one more thing we forgot to write here. That is also I'll tell you. See here. We will give a choice. Enter in node 1. We have written this code. First of all, I'll try to execute. What happens if I execute any errors or anything? And whenever you write null, please try to include stdio.h. Anyway, basically we'll include. Yeah, if you try to execute this one, you can see it is asking enter your choice. Let us suppose I want to enter my choice as 1 to create a node. Yes, I'll give a value something like 30. After giving 30, let us suppose I want to display the elements. Let us see the operation ended successfully, but I want to give the next option. Am I able to? No. Why? Because these option, once it is given, we have written the switch case like this. So in order to make it iteration of taking the next choice also every time. Why? Because inserting the node at the beginning, you want to make every time. So in order to make this part every time, we have to make a while loop here. You can see here. Here I'll write while of 1. 1 means continuously you have to do until what? Where you may ask, like where it will stop. While 1 means it will go infinite, but I have written here a case for, where what is case for means when you give case for exit. Exit means which comes out of entire program. So this is what we missed here. Now we can see the execution part of this one. I'll try to execute whether we'll get the correct outputs or not. And also one more thing we forgot to write here in the display part. What if the list is empty? You have to display, right? Yeah, that also we have to write. If what is that? Temp is equals to null or head is equals to null. Both are same anyway. You can make it initially. You have to print list is empty. Else you are going to this process. If temp is not equals null, then only you have to go to this process. Otherwise you can print simply list is empty. That is also very most important. We'll see anyway. Let us execute this one. I'm executing here. Yeah, initially I'll check it out what is the display. Why? Because initially no elements are there, whether it is printing list is empty or not. Yes, it is printing list is empty. Now I want to give my choice. What is creating a node 1, which is I'll give something like 20. After giving 20, yes, let us see the display part. What are the elements in the linked list? Option 3. Yes, you have one element only in the linked list, which is 20. Now you can give option 2, where you want to insert node at the beginning. Already 20 is there. I want to give 10. Now what should be the output? That means is it 1020 or 2010? Definitely it is 1020. Why? Because node at the beginning. You see the display part. Option 3. Yes, 1020 you can see. Further you want to make it one more node. Option 2, where you want to insert it first. 30, let us suppose. Now you can see the display part. Option 3 I am giving. So it should be 30, 10, 20. Yes, you can see. Now you want to insert one more node. Let us suppose option 2. Let us suppose 50. Now you can see the display part. 50 should come first. So like this, each and every node you can insert at the beginning easily like this. And also, and I told you, like create function. Let us suppose if you give option 1 means whatever the linked list is there, everything will be cleared and freshly you are making your linked list. Let us suppose if I give option 1. Yes, it is asking my node 60, let us suppose. Now if you see the display part, you can clearly observe only 60 will be there. Why? Because everything is clear. So that is what create in the sense means you are creating a fresh linked list. And if you again you can make it option 2 40, so that the display will become 40 60. So like this you can create any number of nodes in the linked list. And finally option 4 if you give, now it will be end of this process. Yes, it comes out. So this is what you can do with respect to the linked list, where you can insert at the beginning. So we have done with creating a node, we have done with inserting node at the beginning and also display part. Now we'll see insert node at the beginning and the remaining things in the next video lectures. Thank you.